Hello, I am going to go over how to find roots of a polynomial, which is on your notes organizer. I'm going to do a video for each problem so that they're short. So when you look at this polynomial, because it has degree 3, we know it has to have 3 zeros. Now they don't all have to be real solutions. They can be complex. We can talk more about that later. But for now, there has to be 3. So it tells you that x equals 2 is a 0. So if x equals 2 is a 0, that means that if you were to change it to a factor, you would do the opposite. So this is one of the factors that divides into the polynomial. Now to find the other zeros, we're putting everything together here. What we're going to do is we're going to take the polynomial and divide it by the factor to see what you have left, and then we try to factor that at the end. So I'm going to put my polynomial in here, and I'm going to divide it by x minus 2. Now you can use synthetic division or long division. I'm going to go ahead and do long division. So remember, you want to see what multiplies with x to get x cubed. It's x squared, and then we distribute. So x squared times x is x cubed. This gives us a minus 2x squared. And in long division, we want to minus everything. So this gives us nothing. 2x squared plus 2x squared is 4x squared. We bring down the next term. And then once again, we look at the first terms here. What do you multiply x by to get 4x squared? You multiply it by 4x. Then I distribute this, so I get 4x squared minus 8x. I'm going to subtract everything. So that cancels. Negative 5 plus 8 is a 3x. Once again, I'm going to bring down the minus 6. And then I look at the first term again. What do you multiply x by to get 3x? It is a 3. I distribute. So I get 3x minus 6. And when I subtract, the remainder is 0. So that means this goes into the polynomial x squared plus 4x plus 3 times. And then what you want to do is try to factor even more. So if you do that, this guy right here using the diamond, you get x plus 3 and x plus 1. Awesome, because now we know what all the zeros are. We have x equals 2, x equals negative 3, and x equals negative 1. So we're going to graph these and try to figure out what the behavior is in between all of the zeros. So we have a 0 at 2, a 0 at negative 3, and a 0 at negative 1. So we need to figure out what's happening between all these points. We can find the y-intercept by plugging in a 0. So that's helpful. That gives us an idea of the behavior. So I have a negative 2 times a 3 times a 1. So this is a negative times a positive is a negative. So it gives me a negative 6 actually. Doesn't really matter. You don't have to give me the exact value, but that's fine. There's no multiplicity. So I know that between here and here, I'm down in the negative area, which means since I don't have a bounce, this is up here, and then it flows through to wrap that up. You can definitely plug in a negative 2 just to make sure. You can plug in a 3 just to make sure, or a negative 4 just to make sure that my graph is correct. Okay? So make sure you understand this first problem. You can look at the video again, and then we're going to go over number 2.